different priority rules will create different sequences. Once you start creating different sequences in job shop scheduling, you then need a way to compare the sequences. That's what's going on here. The cargo manager at Global Freightways Edinburgh Center is concerned that processing the 5 courier jets in alphabetical order isn't necessarily the best sequence. Oh, right. We saw this in the scenario before where they can only process 1 jet at a time, so they just put them in alphabetical order. What else are they supposed to do? Well, let's see. Here's the same old data concerning those jets, how long it takes to process each one and when they're scheduled to leave. And here is some alternate suggestions to to alphabetical order. What sequence does SPT suggest? Now, SPT, shortest processing time. That is a different priority rule than alphabetical order, or EDD, earliest due date. Yes, actually these two rules are very common rules in practice. And then how do these compare to alphabetical order, which is what we had actually looked at last time in scenario 1A. Now, wait. First off, the first 2 questions is asking for the sequences. We have to generate the sequences, although that's not too terribly hard to do. SPT stands for shortest processing time. What sequence would you use for the jets if you were using shortest processing time? It's pretty easy. You look at the jets and you sort them according to processing time. The shortest processing time should go first. You say, well, okay, that's Birmingham. That's the smallest number there. Right. You'd say, okay, Birmingham would go first. And then who's the second shortest? Well, that's Belfast. You'd say, yep. And I'm creating the sequence. Belfast would go next. And then who's the next shortest one? Dublin. And then who's next? Manchester. And the one jet that's the most work to process, the London flight, that would go to the back of the sequence if you're using shortest processing time. So there you go. That's actually the answer to that. I mean, it's answered. Now this one, what sequence does earliest due date suggest? It's a very similar exercise, except you look at the flights and you look at when they're supposed to leave, which is to say, technically when they're due. Okay, who has to leave first? Who is due first? Well, in this case, it's Belfast is the smallest number. That's another way to think about it in that column. Well, Belfast would go to the front of the list. And then who'd be next? Well, Manchester would then move up to second because it's the second smallest number. It's the second soonest departure time. Then Dublin is again in the middle. And then Birmingham. And then once again, actually, because its departure is the farthest out as well, London gets put to the back of the sequence. You say, okay. There, that one is answered. It's this question right here, how do these compare, that's going to obligate us to do a little bit more arithmetic. Because we have the alphabetical sequence, just to sort them in alphabetical order. We now have these 2 other sequences. In order to make any comment, notice that Global Freightways only needs 1 sequence. They just need what order to process these jets. In order to comment on that, what we should do is calculate the flow time and the tardiness associated with each of the sequences so that we can roll that up into average flow time and average tardiness, and then that gives us something which to base a numerical comparison. Oh, all right, so we've got to get organized here because we have 2 different sequences to assess. So one of the things I'm going to do, just so I can keep everything on the same sheet of paper, is I'm going to remind myself that there's 2 sequences. So I'm dividing the workspace that I have left. One of those is shortest processing time. The other one is earliest due date. In each case, I've got the sequence that I need to assess. I'm going to look at flow time, and I'm going to look at tardiness. So I could go ahead and create those headers now. Sequence, flow time, tardiness. So might as well just strike a header there. And there are 5 jets. I just want things to line up nicely, so I'm going to create some guidelines. Second jet, third jet, fourth jet, fifth jet. There's 5 jets. That's good enough, and it gives me some room to write underneath. Okay, because let me think. Shortest processing time. Oh, the sequence. That part's easy. Just copy this way. Birmingham will be first. Belfast will be second because it's the second shortest. Dublin will be third. Manchester will be fourth. And London is at the back of the sequence. I might as well copy in earliest due date as well. Belfast is first in that sequence, earliest due date, then Manchester, then Dublin, then Birmingham, and then London. All right, let's work on shortest processing time. Shortest processing time, the next task is to calculate the flow times. The flow time of a job is when you finish with the job. The flow time for the first job in a sequence is super easy to find because it's just its processing time. For shortest processing time, the first jet we're going to process is Birmingham. We look up here. It is a quarter of an hour's worth of work. That is its flow time. That means it will be done in a quarter of an hour. Belfast has to wait for that quarter of an hour. Belfast is a half an hour. That means Belfast will be finished in 0.25 plus 0.5, 0.75, or 3/4 of an hour from now. Dublin has to wait for 0.75 hours. Dublin is 0.65 hours worth of work. So 0.75 plus 0.65 is 1.4. Dublin will be done in 1.4 hours. Manchester, 1.4 plus 0.75. Manchester will be done in 2.15 hours. And then 2.15 plus London's 1.5 hours worth of processing is 3.65. Oh, good check on my math. When I've reasoned my way down this list, the flow time of the last job should be the same thing as the sum of the duration data. And it is. Good. Okay, average these numbers. Average flow time. I get 1.64. Say, well, okay. Store that away for later. Next, tardiness. Okay, Birmingham will be done in 0.25 hours. I dash up here and look that Birmingham is scheduled to depart in 2.6 hours. It is going to be ready in more than enough time, so the tardiness is 0. Belfast, flow time is 0.75. Belfast, scheduled to depart in 1 hour. Flow time is smaller than due date, 0. Dublin, 1.4 hours is when it will be finished. Dublin, scheduled to depart in 2 hours. It's not tardy either. Manchester, 2.15. That's when it will be finished. Manchester, Manchester was scheduled to depart in 1.5 hours. I've got to do some scratch work here. 2.15 minus 1.5 is 0.65. That 0.65 goes here, because that's exactly how tardy that flight's going to be. London, we have a problem again. London will be finished in 3.65 hours. London was scheduled to depart in 3 hours. So here is another case, coincidentally, where it will be tardy. by exactly 0.65 hours as well. All right, so we've calculated the tardiness in each case. That allows us to then calculate average tardiness by, you average zeros in all these numbers. You get 0.26. Remember, it's just a score. You say, okay. Now, how does it compare to this? Well, we have to repeat the calculations. Let's repeat the calculations. Earliest due date. If we follow earliest due date, Belfast is first up. Belfast will be finished in 0.5 hours. Then Manchester. Manchester waits for 0.5 hours. Manchester is 0.75 hours worth of work, so the flow time for Manchester is 1.25. Dublin waits for 1.25 hours, plus Dublin is 0.65 hours worth of work, so Dublin will be finished in 0.9 hours. The flow time for Birmingham is 1.9 hours, plus 0.25 hours, or 2.15 hours, and then London, the flow time is 2.15 plus 1.5, again 3.65. I was really glad to see that because it also has to match. It has to match here, the flow time of the last job. I don't imagine that the average flow time, however, is going to match what we got last time because we averaged these numbers and I get 1.89. Okay, so right away, and we're still not working on the problem, but right away we can see something, and that's at least with these two particular sequences that we're looking at here, that earliest due date has a somewhat larger flow time than shortest processing time. The interpretation of that is that earliest due date is somewhat less efficient than shortest processing time in moving those jets through the satellite center. Okay, so we want to see a smaller number, and earliest due date is coming in with a somewhat larger number. Anyway, what about tardiness? Let's check that. Belfast will be finished in 0.5 hours. Belfast, look up the due date, so to speak. Belfast is scheduled to depart in an hour, so Belfast will not be tardy. Okay, let's see. Manchester will be finished in 1.25 hours. Manchester scheduled to depart in 1.5 hours. It's cutting it close, but it's still not tardy. Dublin will be finished in 1.9 hours. Dublin scheduled to leave in 2 hours. See, that works also. Birmingham will be finished in 2.15 hours. Birmingham is scheduled to depart in 2.6 hours, so that works as well. So we have now a streak of 4 jets that are all going to be able to leave on time. But then we get to London. And London will be finished in 3.65 hours, and London is still scheduled to depart in 3 hours, which means that if we follow this sequence, London will be 0.65, the difference, hours tardy. Now, performance measure for the whole sequence, not just obsessing on London. We say, all right, well, what's the average tardiness? Average all of these numbers together, which are mostly zeros, and come out with a pretty small number. I get an average tardiness of 0.13 hours. Ah, yes, and notice that the average tardiness for earliest due date is smaller than the average tardiness for shortest processing time. Just a minute ago, we were patting shortest processing time on the head for being more efficient because it had a better average flow time. However, its earliest due date, and this is pretty typical, that has the better average tardiness measure. Not only does it have a lower average tardiness, it is the first sequence that we've seen so far that only delays 1 flight, and that's the one by 0.65 hours. Except, actually, there's 3 sequences in the mix here. These 2 we've just created, but it is asking about alphabetical order. Alphabetical order we looked at in scenario 1A, and I had to go back and look up my notes. Alphabetical, the average flow time was 1.84 hours, and the average tardiness from scenario 1A, if you do them in alphabetical order, was 0.43. So we are asked, how do these two sequences compare to just doing them in alphabetical order? One of the things that we can say is that, well, shortest processing time, it does considerably better with respect to average flow time. It also does better with respect to average tardiness, but nobody does better than earliest due date with respect to average tardiness. Basically, alphabetical doesn't win on either, the first one. Whether you want to declare shortest processing time or earliest due date to be a winner, that would depend on whether you consider efficiency or customer service, which of the two would be essentially the more important of the measures.